Welcome to Neha's Maths Academy. In this video, we are going to learn simple arrangements and selections, that is, combinations and permutations. Let's see some points before moving to examples. First point is, a permutation of n distinct objects is an arrangement or ordering of the n objects. An R permutation of n distinct objects is an arrangement using R of the n objects. What is the difference between first point and second point? In the first point, we have to arrange all n distinct objects out of total n objects. And in the second, it is an arrangement of R distinct objects out of n distinct objects. Now third is an R combination of n distinct objects is an unordered selection or subset of R out of the n objects. That is, select R distinct objects out of n distinct objects. That is R combination. And R permutation is denoted by P and R, and R combination is denoted by C and R, which is also denoted as NPR and NCR. And it is defined as P and R is equal to n factorial upon n minus R factorial, and C and R is equal to n factorial upon R factorial into n minus R factorial. Now let's see some examples. How many ways are there to arrange the cards in a 52 card deck? For the first card, there are 52 choices. For the second, 52, and so on. And for the last, there is only one way. So, by the multiplication principle, total number of ways to arrange 52 cards is 52 into 51 into 50 up to 1, that is 52 factorial. Or just use the first point that we have seen, arrangement of n distinct objects. So here 52 distinct objects are there. So number of ways of arrangement is 52 factorial. Next example, how many different 5-letter words are there with no repeated letters formed from 26-letter alphabet? We have to arrange the 5 letters and no repeated letters are allowed. So we have to firstly select 5 letters and then arrange it. So that this is the second point, that arrangement of R distinct objects out of n distinct objects. Here R is equal to 5 and n is equal to 26. So P26 5, different 5-letter words are there with no repeated letters. Next example. How many ways are there to arrange the 7 letters in the word systems? That means we have to arrange all the letters in this word. Firstly, pick the positions that the 4 different letters E, M, T, Y will occupy in the 7-letter arrangement. See, as systems, there are 3 S's in systems, and S, Y, T, E, M. These are the different letters, and S is repeated 3 times. So let's arrange these 4 letters first. These are the 4 different letters. So this can be arranged in 7 positions by 7 P7 3 ways. That is arrangement of 3 different objects from 7 objects. And then the 3 S's will fill the remaining 3 positions in one way. So there are total P7 4 arrangements. In how many of these arrangements do the three S's appear consecutively? We want these three S's together. It should be consecutive. So we will consider these three S's as one big letter. And remaining letters are M, E, T, Y. And this is one big letter. So this problem is reduced to arrangement of five distinct letters. And how many ways are there to arrange five distinct letters in five positions? There are 5 factorial ways, and 5 factorial is 120. Next example is, how many ways are there to distribute 6 different books among 13 children if no child gets more than one book? There are only 6 different books and 13 children are there. So arrange 6 books among 13 children. Use the formula, that is, use the second point. P13 6 ways to distribute 6 different books among 13 children. How many ways are there to sit 6 different boys and girls along one side of a long table with 12 seats? How many ways if boys and girls alternate seats? First problem is, how many ways are there to sit 6 different boys and girls along one side of a long table with 12 seats? Means these 12 seats are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we have to arrange 6 boys and 6 girls without any condition on this 12 seats. For the first case, there is no condition. So, as there are 12 persons and 12 seats, so there are total 12 factorial ways. So answer will be 12 factorial. But for the second, how many ways if boys and girls alternate seats? There will be two cases. Means on the first case, on the first place there is a boy, and case two is first girl is on the first seat. So if first boy is on the first seat, then what will happen? Then all 6 boys will occupy odd number of seats because one number is occupied with a boy. So, and as we want alternate seats, so 1, 3, 5, 7, 9, 11, these all seats will be occupied by boys. And 6 girls will occupy on 6 even places. 2, 4, 6, 8, 10, 12. So this can be done in 6 factorial into 6 factorial. 6 factorial for 6 boys and 6 factorial for 6 girls. And for the second case, same, girls will occupy even odd number of places and boys will occupy even number of places. So this can also be done in 6 factorial into 6 factorial ways. So by addition principle means if we add these two cases, total number of ways to arrange 6 boys and 6 girls on alternate seats are 6 factorial into 6 factorial plus 6 factorial into 6 factorial. That is equal to 2 into 6 factorial into 6 factorial.